Alright, so we've got our Z set off the bottom of the part. So what I'm going to do is I want to create a silhouette boundary of that part to represent the entire profile. So I'm going to go to my levels, and I'm going to create a level 3. Call this my part wireframe. Okay, so we're going to pick our solid, and with our solid selected, go up here and pick silhouette boundary. It's in the shapes menu, or the shapes section of the menu, silhouette boundary. And make sure you got it set to an arc fit, and then hit OK. And that should create an entire profile of the part. And we put the Z down at the bottom, so it's going to put it down there at the bottom edge. Now I'm going to hold shift, and I'm going to pick these two circles. I'm going to delete those. We don't need them. Okay. And we're ready to create the dynamic contour toolpath. So let's go back to the toolpath manager and go to Toolpaths. And over here in the drop down, pick the dynamic contour. Alright, you'll notice that the chaining menus, a lot of it's grayed out, because really the only thing we can pick is the machining region. We're just picking the contour that we want to machine, just like a normal contour toolpath. The direction matters, so I want to pick this going clockwise, so I'm going to hit the select machining chains. I'm going to switch over to wireframe mode. And then I'm going to make sure it's on full chain for my method. And I'm going to chain this chain down here. I'm going to select this straight wall or this straight edge right here and make sure we're going clockwise so it cuts around the outside of the part. Oh man, I didn't get my picture. I'm not even going to pause the video. I'm just going to get this. This is going to be part of the video. It's picture day. Yep. Every Tuesday and Thursday's dinner day.
And Fridays.
Yeah.
Friday's breakfast. Yeah, still take pictures of food day.
Okay. Tell it OK if you got that chain selected. And then tell it OK here. We can go in and we're going to create this toolpath. I want you to go get your 1/4 inch 3 flute end mill. So go to your select library tool and get a 1/4 inch 3 flute flat end mill. Okay. The chip load for this is a little bit high because it's set up for high feed machining. I want you to, did everybody get it brought in okay? Let's right click on the tool and go to edit tool and go to finalize properties. And let's take the chip load here, the feed per tooth, down to 1.5 thou per tooth. And we're going to feed it at 34. Tell it OK, hit finish, and we'll tell it that we are going to dynamic contour rest mill and finish wall. Cut parameters. For comp and left, all of this can stay just as it is. We don't need to mess with anything here. All these settings look good. We're not flowing the feed rate down or adding any extra material, but on the stock to leave, we are going to do 1% of this tool on the wall, 2.5 thou. And for the floor, since we're breaking through around that outside contour, we'll just hit 0 here. Okay, here's the part of it that does the magic. The contour wall parameter right here. Radius of the tool that shaped the stock. Well, we roughed it with a 1/2 inch, so the radius was a 1/4 inch. The minimum toolpath radius of that 1/2 inch tool, we're doing 10% of the tool or a 32nd, whichever's larger. So it should be 50 thou, 10% of the 1/2 inch tool. And we left 1% of the tool on the wall. 5 thou for the stock thickness.
So this is from the previous tool?
Yeah, from the roughing path that we did around the outside. Okay. We don't need depth cuts for this outer contour because we're not finishing a floor or establishing a depth. We're just finishing the wall size. We do want to finish the wall, so let's turn that on and let's set it to override the feed rate. We'll do 34 times 0.25. The spindle speed was 7750 times 0.5. So slow that down, get us a nicer finish. And then we'll set it to wear comp. Okay. All right. Yes?
Why is wire instead of computer?
What's that?
So why do you choose wire instead of like?
Computer's no compensation at all. Mastercam generates centerline tool movement with no cutter comp codes. Control means that you have to put the radiuses of every tool in at the control. Where you can leave them all 0, Mastercam generates the cutter comp codes and offsets the tool for the centerline. It just basically where keeps you from having to remember to do something when you get out there. Yeah. Lead in, lead out needs to be turned on because we have to have our linear move to turn cutter comp on and off. So we're going to turn that on. I'm going to check mark these boxes up here. I like to enter and exit at the midpoint of the closed contour. And I'm going to do perpendicular 10 and 25% for my line and my arc. I'll do the same thing on the exit. And then I'll tell the overlap to do a 5% of my tool overlap. Breakthrough. Yes, sir. We'll use the breakthrough. We'll do our normal 10% of the tool, 25 thou. I guess it's not really 10%. 25 thou is just kind of my number. 25 thou for flat end mills. And then usually if you have like a bullnose end mill, which means it has a radius nose on it, you gotta go the radius plus 25 thou. If I'm trying to get straight wall, you know, breakthrough all the way, I always go about 25 thou. If I can. Sometimes you don't have that much. So maybe you can't go that far. But linking parameters. We're going to set our clearance to incremental 2 inches above. The retract, I'm going to leave absolute 1/4 inch. The feed plane 100 thou incremental. Top of stock 0. And the depth, I'm going to set that to absolute down to the bottom of the part. So it's absolute negative 1/2 inch. Planes look good. Coolant looks good. I can check mark out, and you can see this contour toolpath. It does the rough, basically the re-rough. That's what all this is. And then right there is the lead in, lead out for the actual finish pass going around after it skims off what it needs to and finishes roughing out this corner with a couple cuts. So if we watch that with the roughing pass, and there it is. There you can see where the 1/4 inch came in and cleaned up the rest of this corner here, and they did a finish pass around the wall. Okay. Everybody's do okay? All right. So that's the dynamic contour toolpath. Contour toolpath is pretty simple. You got, as long as you know what your minimum toolpath radius, the radius of the tool, and whatever your stock to leave was of the tool that you roughed it with, it will go in there and generate whatever it needs to. Let's say I roughed that with a 3/4 inch tool. And I'm not going to change anything about the other toolpath. I'm just going to lie to it in here, and I'm going to tell it, hey, I roughed it with a 3/4 inch tool, so the radius would be 0.375. My minimum toolpath radius would be 75 thou, and my stock thickness would be 7.5 thou. I'll let it regenerate, and you see it has to do a little more work here cleaning out the corner because there's going to be more material left in that corner. Okay, that 3/4 inch tool obviously couldn't have got back in there, so it does a little bit more work cleaning out the corners. Okay. All right. Now we're gonna finish the wall on this step. Okay, with this tool. So we're gonna create some wireframe. We're gonna use the create curve on edges to do that. Okay, so what I want you to do is first let's set our Z depth. Let's set our Z construction depth to the top of this step right here. Should be negative 172.5. If you look down here at the bottom in your status bar, you should see that. Your Z depth should be set at negative 172.5. Okay. And then in the wireframe menu, over here you'll see a curve section, and you see curve on one edge. Now what that lets us do is literally put wireframe on the actual edges as we select them on the solid. So if we pick that, and we want to set it to fit arcs and lines. We don't want to use splines, so set it to arcs and lines only. And then we're going to click each one of these bottom edges one time as we go around the bottom edge of this part. And you see, every time you click one edge, there's a piece of wireframe being created on the edges of the part. Tell it okay. Now we could have used that solid edge and went with like a partial solid chain, but it's just a good time to show you how to create curves on edges using that tool right there. We could have also created a curve on all edges. I could have picked this face and in selection. It'll create that entire, all the edges on that face. And I could have deleted out what I didn't want. Now I got duplicates though, so I'm going to delete duplicates. There we go. All right, everybody got their curves okay? All right, we're going to do another dynamic contour toolpath. And this time for your machining region, pick that edge starting down on this end, going all the way to right here where the red arrow should be. It should chain all the way along. Now, yesterday I had a couple people that they clicked one edge twice, so it created the geometry on the edge, the curve on the edge twice. So they had an overlap, and they had to go back and delete duplicates. So you got to be careful of that. I'm going to do it real quick just so you get to see it, since nobody's did it in here. If you accidentally click, they click like one extra time here, they got 2 arcs there, and then I go to create the toolpath, and I chain this here. When it gets there, it's like, hey, what am I supposed to do? And then they kind of wanted to click it on through. Well, that's okay, but that's not a good way to do it, because a lot of times you'll forget to click that through and send it on the right way. So what I would do is, anytime you're getting ready to start toolpathing, go up here, delete duplicates. That'll get rid of that. And that way you don't have to worry about it. Apparently I kept that toolpath. It's all right. I'll delete it in a second. Okay. So we've got that. We can check mark. We're going to use the same tool. We're doing the same thing basically. We're dynamic, rest mill, and finish contour of step.
What is a rest mill?
Just means it's going to look at what's left behind, and it's going to get the rest of the material in that corner. They call it remachine, they call it rest mill, rest material. Cut parameters. The only thing we need to change in here is we need to leave our 1% on the floor this time, because this is an established depth, and we're using a different tool this time than what we finished the floor on the big part of the step. We're going to have to blend these 2 tools. Okay. Contour wall should be good. We use that 1/2 inch with those same settings. Left 5 thou on there, should be good. Finishing should be good. Lead in, lead out should be good. Breakthrough, I'm going to turn it off. Linking, mine pulled in my depth from my wireframe, so my depth's there already at -172.5. So if my planes look good and my coolant's still good, I have my toolpath. Yes, sir.
If you were doing something like that, when would you want to use depth cuts?
What's that?
When would you want to use depth cuts?
We could use depth cuts since we're going to finish the floor out to the corner there, but it's such a light amount of material anyhow. I mean, we're literally taking well, 2.5 thou off most of the wall, and then even in that little corner there, there's not much left there either. Like right here, as a matter of fact, that one actually it's a 1/2 inch, so there's going to be very little material extra there. So nothing that's going to pull on the tool or anything. So just, depending on how heavy the cut is. Okay. All right. So that's got us. We are all finished. If we watch all this together, we got one last thing to do, and that's put a chamfer around the top edge. We're going to do that just like we always have, using a standard contour toolpath. Okay. Now notice when I watch this and verify, see how we got this little step right here in this corner?
That's what we gotta blend, right?
Okay, that's where we'll have to see that. It's going to be a visual thing probably. That's such a small amount. We're not going to get in there and worry about that too much. Important?
Yeah, I got some parts of each.
Okay. All right. We're not going to worry about that too much, but basically, we could go in there and blend just that corner by dropping the Z down or reducing the tool length for the 1/4 inch a little bit. Yes, sir?
Yeah, I was wondering if this was a visual, because it looks like towards the right side.
All right, here we go. We're going to chamfer this top edge, so we're going to do a normal contour toolpath. We're going to chain the top edge here. Make sure it's going clockwise.
How can I not click the
Okay.
I can't click my.
Go back to solid.
You gotta switch your mode to solids. There you go. Switch your mode back to solids and make sure you're on your solid edges. Probably don't want face turned on. You should be able to pick that top edge. We're gonna use our 3/8 drill mill. RPM we're going to bump up to 7750 because we're milling with it, not drilling. And the feed per tooth is going to be 3 thou. So we're going to feed at 46 inches a minute. Tell it that we're going to chamfer, face, edge, side, number 1. Cut parameters. We're going to switch this to wear. Contour type to 2D chamfer. I'm just going to do a small 5 thou chamfer with a 50 thou bottom offset. As we're running our sweeping arms and everything else, we always want to make sure that chamfer's on our part and make our adjustments before we take it out of the vise. Down here, we're going to do a stock to leave of 5 thou on the wall, which basically is going to put us at 1 to 1. I've been doing 2.5 and 2.5. I'm just going to do the 5 thou on the wall. Same thing. It's keeping it away 5 thou. Just I'm usually doing it a little bit this way and this way. I'm just going to hold it out in the tool radius this time. Okay. Huh? How come? So I can comp it in to get it so it's not too big right out of the gate. Just because those drill mills some of them have pretty good tips on them, some of them don't. So you get a real heavy chamfer right out of the ballpark. So I mean technically we could do this. I just don't like it. I could leave that at 0 and this at 0. Get the same thing, but I like the idea of putting a 5 thou there. That's what I'm after. Okay. All right, lead in, lead out should be perpendicular. We're gonna do 10 and 25. And then the overlap, I'm gonna do 5% of this tool. It's a 3/8 tool, so plug that in. Now come down to linking and make sure our depth and our top of stock are set to that edge, which is at 0. Everything else is going up above that, which looks good. My planes and coolant look good. I should be able to check mark, and there's my chamfer toolpath. Okay, that's side 1 of the knuckle.